Oh, hi there. Thanks so much for showing up here at Math Learning. This one's super tricky, but there's a shortcut that makes it real easy. And I'll talk about the shortcut. I don't think I'll talk about how I wanted to solve it because it goes so far ahead and it's more complicated than it needs to be. But if we go ahead and just calculate the other side, right? We create our common denominator of AC. We get A plus C on top. That is the result of adding that fraction together, and that's equal to 1 on A plus C. If we multiply both sides by A plus C and AC, we end up with AC equals A plus C squared. Okay? And then we simplify A plus C squared to equal A squared plus 2AC plus C squared equals A plus C. Subtract AC from both sides, and we get 0 equals A squared plus AC plus C squared. All right? Recall what we're looking for. A on C cubed. And I used a method to find A on C kind of directly using the quadratic formula and then cube that thing, which is nasty. Okay? Don't do that. Don't need to do that. What we want to notice here is that if we had this situation, A cubed minus C cubed, we've already learned a factorization for that. That's A minus C multiplied by A squared plus AC plus C squared. And we've got that there, this bit. So let's force this. This is fluency, all right? And this is, I'm not as fluent with my differences of cubes and sums of cubes as I am with my difference of squares and sums of squares, okay? So I needed help to notice this shortcut. But when you have this, and it's just a part of your language, math language that you speak, you'll see that you have most of the words, and you'll know that you can multiply here both sides by A minus C. If I multiply the other side of the equation by A minus C, that's just going to be 0. Okay? But the other side, we've created this difference of cubes. A cubed minus C cubed. If we flip that C cubed over to the other side, we basically found that C cubed equals A cubed, which really directly tells us that A cubed over C cubed must be 1. Something divided by itself. So that's our shortcut there. And the way that you can, in the future, spot these shortcuts is by getting really familiar with this, really familiar with A cubed plus C cubed is equal to A plus C multiplied by A squared minus AC plus C squared. Okay? You want to have these locked down so that you can spot where you can force them and then create exactly those expressions. All right? Some other useful things to know. If we have A plus B squared, that's going to give us A squared plus 2AB plus B squared, okay? Which is a useful one. If you can force that in some way, you can create these expressions. That can be very useful. A minus B squared, we looked at that and we used that in a couple problems as well. A squared minus 2AB plus B squared. And then we can force these special factorizations. How about the cubes? Okay, so if I have A plus B all cubed, that's going to give me A cubed plus 3A squared B plus 3AB squared plus B cubed. Okay, so if you've got something in the middle that looks like that, you can force these factorizations as well. Okay, and then similarly, A minus B cubed is equal to A cubed minus 3A squared B plus 3AB squared minus B cubed. Okay, so we're just going to alternate our signs as we go through, as ending up how it works there. I'll let you explore the why. Okay, so that's all what I wanted to cover with that one. Fantastic work, everyone, for sticking with me through the... I do prepare for class, but when I looked at this one, I was like, oh, I can get it there, and then I can divide by c squared and create an a on c directly, and that's going to be easy. And then I was like, oh, wait, actually, it's still really hard. I can do it, but it's really hard. It's super fun. Awesome. Okay, bye for now, everyone.